answering question 7. Sometimes we also have nasty questions like this. Okay, not nasty, just challenging is the right word. You have a question of S over M, T over S, 0, it looks like this, the straight line, then curves, then straight line, and hits it here. The variation with time t of displacement as for car is shown in the figure. So this is variation of displacement against time. On the figure 7.2, sketch the variation with time t of the velocity v of the car. So you have to sketch a graph of the velocity against time. So once again, we know that the gradient is equal to delta s over t, which in this case gives us correctly the velocity. At the beginning, displacement is 0, time is 0, so we have a marker here for our location. Then we also have a graph that is curved, so let us find 2 points. And find another point here, which states that here it is a straight line. So let's call it component 1. And then here, another straight line, component 2. When you have questions like this, always start with the easy points first. So let's do A. Then we go to question 1. Let's put in the times. I'm going to say that we begin here at 5 seconds. Let's say we end the curve at around 35 seconds. We re-begin the curve at around 55 seconds, and we end everything at 100. Once we do this, we can begin our values. Here is quite easy, 100, 0, so let's find. At 5 milliseconds, I say this one is around 50 meters. At around 35, I say it's roughly around 580. Around 55, I say it's around 580 as well. So this is not drawn to scale. Okay, not drawn to scale. Please refer to the graph in the paper itself. I'm just reading off the coordinates so it's easy for you. So, gradient 1. Again, put in the brackets for coordinates, put in your units, in this case it's meter and seconds. Our final point here is 580 meters, 35 seconds. 580 meters and 35 seconds. Next one, 50 meters and 5 seconds. 50 meters and 5 seconds. So please calculate this value. Here, this is going to be a positive gradient. Now, gradient 2. Again, put in the brackets. Minus, brackets, minus, put in the units, meters per second. Our final position here is 100, 0, 100 meters, 0 seconds. Oh, apologies. It's actually 0 meters, 100 seconds. 0 meters, 100 seconds. realize how easy it is to actually do a mistake here. Thank goodness we have the units at the end, and thank goodness we use the approach where we choose coordinates and then we verify. Okay, so next one. Our initial point here was 580 meters, 55 seconds. 580 meters, 55 seconds. Okay, so verification complete. And then over here you have a negative gradient. I'll let you calculate what the values are, make sure the values are correct. Put it in this graph, you need to put in the scale. Okay, so I'm just going to show you what the shape is going to look like. For example, this one is a positive gradient, so over here. And the good thing about this is the gradient here, 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 and here are all the same, constant. So you'll probably have a value that looks like this. Here is negative gradient. The gradient is constant here, 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 and here. So, but it goes back to zero displacement at 100 seconds. Means you're looking at your velocity ending here. So we finish that end part. So there's 1, there's 2, there's 3. Now, from 0 to the beginning, how do we do this? Quite easy, it's curve. That means increasing, so the velocity is increasing non-stop. So we can draw a straight line here and label this 4. Don't worry about calculation here, okay? It will be too much to actually calculate it because the grid is not zoomed in enough to actually do that. So we just connect the line here just to show that we know at this particular point velocity is increasing, okay? So don't worry so much about it. Then we find the peak. The peak is here at the middle, so let's say the peak is here. Why? Remember, gradient at peak is equal to 0, and what does gradient here represent? It represents the velocity. So you can't just connect the line straight from top to bottom, okay? Because at the middle we know it's 0. So you connect a straight line here. Because it curves, it shows that it's slowly decreasing to 0. So it's slowly decreasing to 0, okay? Over here, it's slowly increasing from 0 to negative velocity. Means you're moving in the opposite direction. So from here, you connect a straight line. Okay, so 1, 2, 3, 4, 5 for this middle point here.